So I'm Andy Sipocz, with the Texas Parks and Wildlife Department, the State Parks Division. I'm with the regional office, which is headquartered out of Sheldon Lake State Park. There are 6 regional offices in the state, and within each regional office is a biologist that essentially is responsible for managing the natural aspects of the state parks in the region. So I work with everything from Lake Somerville State Park to Mission Tejas up here in Nacogdoches, Martin Dyes, near the Louisiana border, East Texas, on the Neches River, Village Creek, Galveston Island, Sea Rim, Brazos Bend. All those are my parks. There's about 20 of them in this area. And most all of them have native plant communities associated with the parks. Parks were usually purchased and set aside. A lot of them were donations. They're not like national parks in that some outstanding natural pristine area was identified and so a park was set up around it, like Yellowstone. They're more like somebody's ranch who knew a legislator who was talking to donating it, sort of a thing. For instance, Galveston Island State Park was a hobby ranch of the Stewarts. Brazos Bend State Park was a hunting club of the Hale Timber Corporation, so on and so forth. Very few of them were actually, well, none of them in this area were actually set up to preserve a specific natural area. So all of these parks have been impacted in the past through some sorts of land management, and because of that, there is a lot of restoration needs at the parks. As Wally was stating, at Sheldon Lake State Park, most all of that park had been farmed in the past. It actually had some really great prairie on it, but it was a fish and wildlife area, and they plowed the prairie up to plant rice for the geese back in the 50s. So we're trying to restore that back to prairie now. But what I'm going to do is just talk to you about the region's plant communities. This will take hopefully half an hour. Is that going to work? Okay. So let's start off. I want to talk about a few things that I've learned in this business. I've started with state parks in 2005. I started with the department in 1990. I moved to Texas in 1985 to get my master's degree and did my thesis work at the San Bernardino National Wildlife Refuge. But most of my time has been spent in Southeast Texas. So rule number 1 is to conserve wild things in their habitats, we must know them and understand how they live and interact. You really need to know more about a plant than its DNA. You know, it's very, even though the study of natural history is kind of passé in universities today, it's vital to understanding plant communities, how they came about, and what is required to sustain them. And this is from a book written in 2013. This isn't some quote from some guy, 100 years ago. Poor training in natural history leads to second-rate conservation, and that is absolutely true. There's a heck of a lot of second-rate conservation going on these days. A friend of mine, Mark Miller, a guy I went to graduate school with, said that geology is the basis of ecology, and he's absolutely right. Geology is really ultimately what controls the distribution and abundance of plants. And of course, the study of the distribution and abundance of organisms on the face of the earth is the definition of ecology. This is the area that Wally helped restore. This was a rice field. This is out of Sheldon Lake State Park. So you got a nice depressional wetland here. A couple feet of water in the middle. You got some upland prairie here and some pine and cypress savanna in the background there. All this was rice fields until 2003. That's when the restoration began. So if we look at the region's ecology, this is a geologic map of the state of Texas, and what I want you to notice is this is all kind of mixed up stuff up here. But if you look at the coastal plain, everything, all the different geologic layers, it's like a layer cake as you go towards the coast. They're all in bands that are parallel with the coast. And the reason for that is this is all accumulated sediment since about the time of the dinosaurs, a little earlier than that, a little earlier than the Cretaceous, but all this is fairly recent sediments, recent in geologic time, that the rivers have brought down, especially with the uplift of the Rockies, that the rivers have brought down into the Gulf of Mexico, and all that sediment has accumulated there along the coast and has slowly built the coast of Texas further and further out into the Gulf. And the way this occurs is that if you think of the Earth is actually not like solid, all right? The mantle is kind of squishy. So you have these rivers bringing down sediments, and right here on the coast today, if you go down like a Galveston Island and you dug down, you'd find about 40,000 feet of accumulated sediment. That's a lot. It weighs an awful lot. It actually pushes down on the Earth's mantle. And the Earth is just like a balloon. If you squeeze one part, another part gets squeezed out. So as these sediments get dumped into the Gulf, think of the shoreline as a fulcrum of a lever or a seesaw. As all this stuff gets dumped in the Gulf, the land inland gets jacked up because of the weight being pushed on here. So even though this is built out from what used to be the Gulf of Mexico, it's not that the ocean was up to here at one point, it's that this land has been lifted up over time. So you've got two things going on. You've got this land here sinking and this land here rising up, and so all of these past layers of river sediments are being brought up to the surface and exposed. And that is extremely important in determining what the heck we have down here on the coast. If you look at this is a topographic map of the coastal plain. Here's Galveston Bay. You see that inland here around College Station, it's a very dissected area, but right on the coast, it's very flat because it's essentially a series of coalesced river deltas. It's just like you think of the Mississippi Delta, which is out in the Gulf. Well, these are where the rivers come down out of this high ground. They dump, they hit this flat coastal plain. They dump their sediments out right there. And you have this series of coalesced river deltas that have built up this large coastal plain. And because the sediments are being brought down from the rivers in a relatively arid area, they're bringing down very, very fine sediment particles, mostly clays. So if you think about what's our soil here in Houston, it's gumbo clay. That's kind of a unique thing in the world, in that for the most part you do not have these very dense, very impermeable clays in humid areas. The reason we have them here is because the sediments from a desert area were brought down into this wet, humid environment. So we have a gumbo clay and a very flat topography in an area that gets a lot of rain. And the result is two things: a lot of wetlands and a lot of prairie. Trees do not like soils that go from being inundated to being hard as a brick. Grasses, however, do very well. Grasses and herbs do very well under those conditions. Also, because it's flat as a board, fires travel across this landscape very easily. Because it's essentially a river delta, we don't have a lot of little creeks dissecting it, so there's very few natural fire breaks. The end result is that, for the most part, the coastal plain, even though we get over 50 inches of rain a year, is dominated by grasses. And again, if you look at the natural subregions of Texas, the various ecosystems, they tend to follow the state's geology. Again, the vegetation types. So geology is the basis of community types and boundaries. Climate is important, but think about this. We've got prairie here, down in these deep sands where they get about 25 inches of rain a year. We got prairie here where we get over on the Louisiana border where they get about 60 inches of rain a year. So it's obviously not just climate that's controlling these plant communities. It's very important to realize that edaphic or soil plays an incredibly important role in determining what plants you have growing where. So if we look at somewhere like Kentucky, you know, there actually is a small area of prairie in Kentucky. And the reason is because if you think about Mammoth Cave, you've got all this limestone that's brought up to the surface. As it's eroded over the years, you have an area where the parent material, the rock, was just the right kind that when it decomposed, it made a very dense clay soil. And they essentially have a little area of blackland prairie right there in Kentucky, just like we have in the limestone soils south of Dallas, just like they have through an arc through Alabama and Mississippi, an area of tall grass prairie there as well. So just realize that geology is extremely important in determining plant communities. And it's important today because so many of our native plant communities have been kind of messed up through benign neglect or through past farming or other management, that it's often hard to tell what the heck used to be there. And if we want to restore a native landscape to a state park, we've kind of had to do some detective work. And the first thing you do is you look at the soil maps of the area. Now, something else I want to show you about the vegetation of Texas. Brown is farmland. Light green here is essentially tree farms where the pines don't get more than about 20 or 30 years before they're harvested. And you'll notice that most all of this area here in southeast Texas, most everything up in the Panhandle, there's very little in terms of native plant communities that are left. Very, very, very little. When you drive in East Texas, if you look beyond the beauty strip along the highway, you just see little 30-foot tall pine trees. In regards to plant diversity, it's not a heck of a lot different than like what you would see on the edge of a cornfield. You know, it's gone. Okay, let's start with coastal prairie. And again, this is a map of these gumbo clay soils, and you'll notice we've got them right here along the coast and in the Mississippi Valley. And other than that, look here at the eastern U.S. It's essentially, there aren't any, except that arc I was telling you about here and a little bit up in Kentucky. And where you see those, other than in the Mississippi Valley, you see prairies. And again, this is the geology I discussed here on the coastal plain, where if you were to look at these, these are different geologic ages, and what you've got are these overlapping deltas, in this case of the Colorado River. And what happens is each time we have an ice age, the ice age ends, the ice melts, the sea level comes up. The rivers that were gushing down, you know, into the ocean that was 400 feet below where it is today, it's a lot of drop, so there were really rapid flowing rivers. Well, as the ocean rises, those rivers suddenly, they don't have any slope to them. They start dumping their sediment overboard, and the river starts jumping out of its banks and flowing back and forth. And you get these big deltas, inland deltas created, and then we have another ice age. The river will cut down through that, and we'll stop building a delta. The ice again melts, the ocean comes up, and the river finds a new place to go and starts the whole process over again. And over time, it's created the whole coastal plain of the state, which is really the heart of where we find our prairies. So how many ice ages have we had? They're a relatively new phenomenon on Earth.
20, I'd say.
20? Close. 41.
Oh my God.
Yes. And it's kind of neat because geologists in the 50s and 60s thought we only had 3. So we're learning a lot as time goes on. So they started out being relatively fast, 40,000 year cycles, and didn't get quite as cold. And then because of the sun and the earth and orbits and stuff that I don't understand, or actually maybe even the changing of the continents themselves, they started becoming deeper and longer. Okay. So one thing I want you to notice is that because the coastal plain really is nothing but a bunch of overlapping river deltas, you still find all these old river channels all over the coast. Anywhere that hasn't been land leveled, you will find them. So this is an astronaut shot one of the Apollo missions. Here's Houston. They're taking a picture of home. You can really see that, yes, we do live on a delta. So here's about Freeport. There's Houston. Bay City is about over there. And if you look at some elevations on Google Earth, here's an oblique view. This is Houston. This is an actual collection of aerial photographs. Here's the modern Brazos. If you jump right up on the high bank of the Brazos, it's about 56 feet at this point. Whereas if you go down towards Chocolate Bayou, it's only 53 feet. What does that tell you when the river, the edge of the river is higher than basically most all of Houston? When we think about where the river is, like Mississippi River in Louisiana, like New Orleans is perched on that high ground right on the river, and everything back from it is swamp. And every now and then that river just wants to shift into that low ground and set up a whole new thing. Well, the Brazos is way overdue. It's wanting to shift back, maybe through downtown here, or maybe down to the coast over here, most likely. So I'm just waiting for that big flood. So, which we've not had on the Brazos. You know, it's, I think the most it's had is like 120,000 cubic feet per second. The San Jacinto has beat that. What's going on with the Brazos is they've got all these flood control reservoirs up in the main watershed of it, and so it doesn't flood as much. But if we'd had all the reservoirs finally had gotten filled up 2 springs ago, and if we'd had one more heavy rain, that river's capable of pushing down about 500,000 cubic feet per second, which would be like 3 or 4, about 4 Trinity rivers when a Trinity's at its very highest. You could not imagine what that would look like. So the geologists have estimated that the Brazos now only carries about 10% of the sediment that it used to. So the flows have really been, the flood flows have really been attenuated on it. But this is the result of this land having been developed from river deltas, is that if you look on the landscape, and these are old 1930 aerial photos, you still see all these old, look at this looping river channel here. Here you got all this is an old river channel. All these are old deltaic, distributary channels. And these are, how old are they? This is maybe 80,000 years old. Some of this stuff further north and towards Houston out on the Katy Prairie is probably 500,000 years old or something like that. And over time, the landscape is being modified by wind and water erosion. So we've not always, our climate is not stable. About 8,000 years ago, the northern hemisphere during the summer, the Earth was a little more tilted than it is today, and the northern hemisphere used to get more sun in the summer and less sun in the winter than it does today. So we actually had warmer summers and colder winters about 8,000 years ago. And at that time, right now during our summer, the Earth is actually further from the sun than it is during our winter, the northern hemisphere, summer and winter. 8,000 years ago, the northern hemisphere was not only tilted closer to the sun, but in the summer it was actually at its closest point to the sun and furthest in the winter. So we had much warmer summers and much colder winters. The average temperature of the Earth was slightly less than it is today, but the summers were hotter and drier. And the result is much of this part of Texas had quite horrendously hot, dry summers, probably a climate more like you see typical of a summer like in the Dallas area than what we have today. And the result is that this landscape would be partially denuded, and we had a lot of wind erosion. So all these white dots you see in these photos are Mima Mounds. Mima Mounds are nothing more than coppice dunes. They're actually sand dunes. I know there's a lot of different hypotheses out there about what created Mima Mounds, gophers, earthquakes, ancient mammals, alien landing spots. But the geologists have kind of recently put the nail in the coffin of all the alternate theories, and these are essentially your Coppice dunes, and there's a number of reasons why they've determined that. But what you've got going on in this landscape is these old river channels hold water. During the summer, they would dry out, so you have these exposed, bare, dirt bottom marsh areas, and the wind would pick the dirt up out of these channels, mostly the sands, and deposit them on the upland landscapes. So over time, these river channels actually get obliterated by wind erosion, and what you have left are just where used to be a channel, you have just a series of round or somewhat round ponds, almost like a string of pearls following what used to be the old channel. Instead of a long, sinuous wetland, you now have a string of round ponds. And round because the wind likes to blow round things in round shapes. I don't know why, it's physics, and I don't understand it all, but you end up with a landscape that has high little sandy mounds, big drainage swales, and a gazillion round marsh ponds. Those little dark spots you see are all marsh ponds. They used to be probably averaged about 1.5 feet deep, maybe 2 feet deep in the middle. They were anywhere from maybe an acre to 10 acres in size, and there were just a gazillion of them. And for the most part, this landscape you see in these 1930 photos, this was an incredible landscape of prairie. Anywhere you have these old river channels, you would have the old sand banks along them. Often there you would have in that sand, unlike the black gumbo clay soils, the sands will hold any kind of little rain we get in the summer. They'll hold that water and make it available because the rain percolates down into that sand and then sits on the clay down below and is held there like a reservoir. So they're great places for trees. So this was a prairie with islands of trees. Anywhere you had these deep sandy soils, and otherwise you would have marshes and dry prairies and then Mima Mounds, and on the edges of Mima Mounds you would have these alkaline rings of soil that had a lot of different rare plants in them. It's just a really cool landscape, but for the most part it's all gone now. It's all been converted to rice farming. This is near Brazos Bend State Park. This is a really cool topographic map that a fellow made by massaging some LiDAR data, which is just topography is derived by a plane shooting a laser down at the ground. The dark green is higher, the purple is lower, but you can see the old river channel, and you can see how the channel is being modified by wind erosion, and you can see how these areas outside of the channel are being built up as the sediments from the channel blow into the adjacent upland vegetation. So this is what that area looks like today. This is still in existence. Still has all these little green dots or Mima Mounds. So this is still some intact prairie. It's gorgeous. If you go out there, it looks flat as a board, but when you really start picking your way across the landscape, you start walking into water, and then you're dry, and then you're wet, and the plant community is constantly changing in response to those changing physical parameters. So who knows this spot?
Nash Prairie.
Yes, this is the Nash Prairie. And this is down south on the Powderhorn Ranch, which is a new wildlife management area and state park. It will be open to the public soon, about 15,000 acres down near Lavaca. And it's drier down in South Texas. And so this process, which happened here during 8,000 years ago when we had those hotter, drier summers, it's still occurring. Every day, every summer, these wetlands dry out, and you get these white sandy soils, really alkaline soils, and the sand blows out of the wetland when it dries into the adjacent uplands. You see you've got an actual dune formed here with trees growing on the dunes. That gives you an idea of exactly what the Houston area looked like back then. And pollen studies confirm that. People digging down into old sediments and seeing what kind of pollen was deposited. So I'm not going to go into a lot of details. Another way we know, understand the geology of the area is that geologists are now able to take sand grains. If you can get a chunk of soil, don't expose it to light, take the soil into a lab, you wash the sand grains with a lot of different chemicals, and then you expose that sand grain to a certain wavelength of light, and it will phosphoresce back a different wavelength, and that different wavelength tells you how long it's been since that sand grain was last exposed to the sun. And that goes, it's better than carbon dating because you can go back like 100,000 years. It's accurate, like I guess, I don't know that there is an end date to it. So geologists can now tell, oh yeah, all these Mima Mounds formed within just a few hundred years, 8,000 years ago, when the climate was really dry. Ah, they're sand dunes, it makes sense, you know. Another process that's going on is that these soils are fairly alkaline. They have a lot of salts in them, a lot of calcium, a lot of manganese, a lot of magnesium, a lot of potassium, because they are derived from marine sediments inland, like around Midland, Odessa, Cretaceous marine sediments. And because they have some salinity in them, there are times of the year, and I don't understand the soil chemistry, pyrolysis and some other things are going on, where the soil essentially melts. It falls apart when it gets wet. Normally the soil is made up of particles that are all adhered together with organic matter and other things. Well, those particles can essentially dissolve in water, and the sands stay in place, and the fine-grained clays wash off with the landscape. And essentially what I'm showing here is the land is kind of melting away. So if you remember some of these photos, it kind of looks like, that's not a good one. Yeah, right here. See the water coming out of these ponds, and these dark areas are lower swales. It's almost like the land is just like melting away, like water dropping onto a big sugar cube. That's exactly what's going on. It's another way that these landscapes have been shaped. The end result is we used to have this just incredible coastal plain. Here's an old river channel with these light white sandy sediments over here, and all these ponds being formed out of what was a channel. This is the area of the Katy Prairie. You had an area, we know that the prairie absorbs a lot of water. Well, it absorbs a lot more water than the engineers will tell you it absorbs, because it used to look like that, and the storage there was just absolutely tremendous. Once you level all that for rice farming, you lose and make a plow pan so the water doesn't percolate, you lose a lot of water retention, and you exacerbate flooding in Houston. So it's not just concrete that's increasing the flooding, it was rice farming itself. It probably greatly increased the flood problem in Houston. And again, just the extent of coastal prairie in Texas and Louisiana. Here it is in the Houston area, the coastal prairie. You see where the modern river channels are, the modern floodplains of the Brazos. And then as you go east, the San Jacinto and the Trinity River, you would have forest with prairies in between. It must have been just a magnificent landscape at one point. I've got an old article from a popular magazine from, I believe, the 1830s, 1840s. Where they're talking about hunting jaguars around San Jacinto, where the battleground is today. Imagine that, bison, jaguars, mountain lions, bears. Must have been awesome. So here's Brazos Bend today. This is the tallgrass prairie plant community, the one I'm spending the most time on because it's the one I'm working with the most at this point. But you can see this is the old Brazos River channel from long ago. It's now got a marsh in the middle of it. Here's the old riverbank, sandy riverbank, where you have dry prairie. You've got live oak dominated forest again on the bank, and the old sandbars. Really neat landscape. So you have like brown seed paspalum, big blue stem, the live oak and persimmon, and
a lot of the asters and herbs on the drier land, and down in the wet areas you have things like grassy arrowhead, Sagittaria graminea, platyphylla, Sagittaria platyphylla. And in between you get the wetter grasses like switchgrass and gama grass, and long spiked tridens, and Florida paspalum. And you can, this is right after a prescribed fire we ran across here the previous winter. So you can see the little tips of the Mima Mounds poking up, and you can see all the baptisia, the false indigo growing right there around that Mima Mound. They like that. So when you had an intact landscape like this, the plant community changed, greatly from one spot to another, because the soil and the wetness of the soil changed greatly from just within a few feet. And one of the things that I've really been pushing in landscape restoration on our state parks, the areas that have been farmed, is to, as much as we can, rebuild that soil and topography, those changes, in order to support a more diverse native plant community. If you look at a prairie remnant, it may have 300 species of plants on it. But if you take those 300 species and seed them into an old rice field, you're not going to have all the ecological niches to support those 300 species. You're going to end up with just the stuff that kind of grows in that middle mesic kind of a habitat. And again, this is the Marsh area, and you can just see this was an old river channel, and you can see the bank of the river is just solid forest there. That's the way it's always been. And the settler descriptions of the prairie was that you would have these islands and strings of trees. And they're not, the islands of trees and the strings of trees aren't just associated with like creek banks like Cypress Creek, but they're mostly were associated with these old channel features. This is the Dick Benoit Prairie Park in League City off Highway 96. So, and this is an area just north of West Bay. It's neat as you go down towards Galveston Bay and West Bay, the land transitions from upland prairie into salt marsh, and you have these features out in the salt marsh. They're just inundated now as sea level has risen. And so even within the marsh areas themselves, you get changes in the plant communities because of this. And these are some Mima Mounds. When they're really heavily grazed, you can see them real well. So these are the Mima Mounds there. And we're looking for rare plants in between. So the rainfall hits those sandy Mima Mounds. They're dunes after all. They're pure sand. Soaks right into them. But then it hits the clay underneath that sand accumulated on. And the water has nowhere to go, so it leaks out the sides of the mounds. And as it leaks out, it evaporates and it leaves behind any of the dissolved salts. So you have these salt rings around those mounds that have maybe a pH of 8.2, 8.5. And it's really hard for plants to grow there, so there's a whole set of very rare plants that are just found in these rings. And you saw those old pictures. There must have been 1 million of these salt rings back in the 1930s and 40s, so it wasn't like it was a super rare habitat, but today it is incredibly rare. So prairie dawn, Texas windmill grass, Grand Prairie primrose, which probably doesn't exist in Texas anymore. A lot of these were only found in these salt rings. We actually found a bunch of sundew. You find lots of sundew in the sand right on the edge where the water weeps out. They like that wet environment. And there's the white soil you see there. So you see the sundew at the top, and then that weird Indian blanket that doesn't have any of the, it only has the rafe flowers. And then this is just the tall grass prairie. That's at the University of Houston Coastal Center, Gulf fritillary and blue mist flower. We manage all of our prairies with fire. Fire is great. A lot of times people will see brush and they kind of, They're like, what's wrong? What's wrong? What's wrong with your park? It's nothing but brush. And the deal is that along the roads where people drive is brush because the fires start at the edge of the road, and it's really cool when it starts and then it blazes up. So if you just get out of your car and walk through that line of brush, you'll see the beautiful prairie. So this is the park after we burned it up. It had been a long time since it had been burned, and when we first burned it, everybody was like, "You killed the park." What really killed it was farming, was the first thing. What you see here in this photo is the farmers have followed that old river channel, and they've dug a ditch and linked all of the ponds. You see these are ditches, these squirrely little things. Those used to be, they were dug down at the bottom of what were the river channels, and they link all the ponds so they could drain them. That's the first step in the farming operation. And of course, housing today. Most of the prairie that's left is right here in Houston, because everything outside of Houston has been farmed. But right here in Houston, when I say in Houston, I mean in the city limits, and in the city limits especially of the smaller towns like Deer Park and Pasadena and League City. That's where the prairies are, because those lands have been held by speculators since the 1800s. When you hold land for speculation, you don't bother farming it. You may stick a few cattle on it to get an ag exemption, but for the most part, you're just waiting for it to increase in value and have somebody come pay you $50 million. Isn't that what the Deer Park Prairie costs land? $50 million. So the way we're losing our prairies today is through housing developments. That's the Dick Benoit Prairie Park. There's homes right up to the edge of that. So what we're trying to do is preserve some of this landscape in our state parks, but we have very little good prairie left in our state parks. So we're having to restore it. This is the area that Wally was talking about, our Phase 1 restoration area. This is an area at San Jacinto that had been prairie until the 1960s, and then it got covered in with tallow. The land was donated to the park by Shell in the early 1990s. We chipped the tallow and then reseeded it with prairie grasses. That's mostly long spiked tridents. And if any of y'all go out to San Jacinto, it's going to look really horrible because we've just applied some herbicide for brush control. The guy who knows herbicide better than me says, "Don't freak out, Andy. It's going to be fine." But it really looks horrible right now. So I'll warn you if you go out there. Okay, so here's the next thing. Next plant community I want to talk about is Pine Oak Savannah. This is what they're trying to restore out here. This is what we had at the Arboretum. So if you go out on the Arboretum grounds, you'll notice there's lots of little trees, lots of little willow oaks and such, lots of little pines, and then there's big, huge post oaks and some big, huge loblolly pine. It used to be that you would just have these little motts or copses or little islands, clumps of trees, and they were surrounded by open prairie. So the open prairie are on these dense clay soils. What were the pine trees growing on? Sandy Mima Mounds, right? Mostly Mima Mounds. So one of the things we discussed, remember we were talking about restoration, was what the savanna should look like. And what I was saying is it's not just evenly spaced trees. The trees that you want to leave are the ones that are on these old Mima deposits, and then you have big cleared areas around it. So the trees were really bunched on the landscape. Okay, let's move into Piney Woods. So if you recall that geologic map, as you go from west to east, we're going from like the Guadalupe River, the Nueces River, Lavaca River, Colorado River, Brazos River, San Jacinto, and when you hit the San Jacinto River, and then the Trinity, and then the Neches River. Those rivers are not bringing sediments down from the arid areas in central, well, I mean the Brazos starts in New Mexico. They're not bringing sediments down from those arid regions. They're bringing more sandier sediments from a whole different eroded out of a different geologic strata. And because they're bringing down sand, you still have areas of dense clay soils that are prairies, but you have much larger areas that were nice sandy loams. And the native plant community on that are what we term our piney woods. The piney woods are there not because it rains more in East Texas, but because it's that different, it's a soil that's much better for growing trees than our clay soils. And this is Martin Dye's Junior State Park, which is, if you want to see really beautiful forest, it's this tiny little state park on the B.A. Steinhagen Reservoir, but it's a great place to go if you want to see some beautiful, diverse upland pine forest. So you'll see the magnolia and beech mixed in with the pine and the sweet gum and cypress down in the bottoms. It's really gorgeous. Very high diversity of plants. The thing about the piney woods is that especially the areas dominated by longleaf pine, is that fire was also a very, very important component of these woods. And so all throughout the piney woods that really extend along the entire Gulf of Mexico coastline into Florida and into North Carolina, up to East Coast up North Carolina, you had enough fire to keep enough of the forest open such that it still has essentially prairie underneath. Really all it is prairie with some pine trees on it. Most of the plant diversity in the piney woods are herbs that are grassland. Essentially it's a grassland community. That's where the diversity is, with some trees on it. Now you do have areas that don't ever burn, and that's where you start getting a real good diversity of broadleaf trees like southern sugar maple and such. And as you go east, the amount of lightning increases, so that by the time you get to Florida, western Florida has like more lightning strikes than anywhere outside of the Amazon, I think. It's just incredible. The average return interval for fire in parts of Florida is 1 year. It burns every single year, and that's the natural lightning-caused fires. You get some neat things that are sandy soil specialists like town ants or leafcutter ants. And again, I just want to point out that for the most part, the piney woods are gone. When you zoom in, you realize that it kind of looks green from a really long ways away, but most all of it is either tree farms or pasture. The number one cause of loss of forest in the southeastern U.S. until recently was conversion to pasture land. It's just small landowners wanting to have like limousine cattle or something because it's easier to grow cattle than trees, I guess. I don't know. They get their ag exemption. We don't use as much paper as we used to. People don't read newspapers. So folks like Temple Inland and Champion and International Paper, they used to own millions of acres of forest land. They're divesting themselves of all that forest land. It's going into small land ownership. A lot of that is second home development, which is, I believe, now the number one cause of forest loss in the southeast U.S., but a lot of it is being converted to pasture as well. People just like to have the idea of, yeah, I got 100 head of cows. So somebody comes in and cuts the trees and they don't ever get planted back. This is the Sam Houston National Forest. There. It's like a little island. So when people complain about the National Forest Service cutting their trees, it's not so much because people are like crazy environmentalists these days. It's that when the National Forest was established, it was surrounded by private forest land, and it was no big deal to cut trees on the National Forest. Well, today, it's the only forest we got left. Why cut any trees on it? Why harvest any trees? There's more than enough private forest land to provide our lumber needs. Why do they do it? It's just inertia. I don't know. That's just me going on and complaining about stuff. Okay, when you get further inland, if you remember, it's like bands of geology as you go inland, all the way up to the Balcones Escarpment. that's really the edge of the coastal plain, is the Balcones Escarpment, right as you come up into Austin. Well, some of these geologic layers were laid down during periods when the sediments being brought down towards the Gulf were much different than what we have today. Instead of clays, they were bringing down sands. And so you've got this narrow band of deep sand that goes from northeast Texas all down through Leon County. Does anybody know where that? Gus Engeling Wildlife Management Area. Like near Madisonville, north of Huntsville, that area. Where you have these very, very deep sands, and you get some really awesome plant communities on there. A lot of it is like post Oak Savannah. Have any of y'all been to Fort Boggy State Park? Yes, great. You guys, if you're interested in botany, if you like plants, go to Fort Boggy State Park. You will not be disappointed. We've got some old growth sand post oak forest there. We've got some old growth mesic forest there. We've got some beautiful prairie openings there. A lot of it had been farmed and degraded, but there's still a lot of it that's just magnificent. You have stuff like butterfly weed and this field of coreopsis. And then this is Centerville mint. So if you want to put that on your life list, it's like a little blue mint you will find. It's a new species. It hasn't been published yet. Eric Keith is going to publish it. Maybe he has. I'm just behind the times. But it's found just on these Sparta sands. He's named it Centerville mint because it grows around Centerville, Texas. So cool. And this is what it looks like. You have like blackjack oak and little blue stem prairie, or sand post oak and little blue stem prairie. It's really neat. It's a deep sand, so you have this like almost an elfin forest where the sand post oaks are they're maybe 20 feet tall, and they're all gnarly. And then it's just so cool just to walk through it. And then down on the river bottoms, you have things like this. This is the Davis Hill State Natural Area that Joe has done so much work on with the orchids. Down in the bottoms there, you got just some magnificent bottomland hardwoods with big cypress trees and nuttall oak. And Ted Hollingsworth says there's a black willow that's 12 feet in diameter. I've never been able to find it, but I'd love to find it. There's some beautiful pecan bottoms down there. This is along the Trinity River, north of Liberty. So this is another one of our really important plant communities in East Texas, which are our bottomland hardwood forests and cypress tupelo swamps. Because most of these swamps have been harvested back in the late 1800s, early 1900s, but a lot of them haven't been touched since. So just because of the different demand for different types of wood. You know, right now it's all about pulp production. It's all about 2x4 production. The best way to do that is with loblolly pine. So people aren't necessarily going down into these bottomlands and cutting the trees much anymore. So there's just some magnificent areas down there that can be found. Yes? That's the Davis Hill State Natural Area. On the Trinity River. There's a salt dome there. The salt dome, you know, the salt, it rises up through the earth because it's lighter than the surrounding rock. Because remember, you're laying sediments down on the bottom of the Gulf of Mexico, so you're laying dirt on top of big, thick layers of salt, because the Gulf has been cut off from the Atlantic and has dried up periodically in geologic time. So there's huge layers of salt, thousands of feet thick down there. Well, that salt bubbles up through the other strata that have been laid on top of it, and as they bubble up, push up like a lava lamp, you know, but in super slow motion, it pushes these sandstones and up into these big domes. So you've got this, which is exposed sandstone rock, sitting about 250 feet in elevation above the Trinity River. So you have this incredible gradation of plant communities from bald cypress swamp up to the top of this salt dome, which essentially has a barren, little grassland barren areas on it.
That area is not usually open, right?
It's not, but you know, talk to Joe. He can take you out there. The problem is we don't have anywhere for visitors to park, and it's not in the best neighborhood. We have no way to keep our visitors safe, so it's not open to the public yet. And there's a lot of private inholdings, so you can very easily wander onto private land, and the landowners have guns and stuff. So That's why it's not open to the public. But Joe's done a lot of work out there. These ravines and this sandstone that's been pushed up, the sandstone is fractured, and you get these little gullies that develop that erode out of the fractures, and you get these really cool rocky landscapes right there in East Texas, just north of Liberty. And Joe did a lot of work on orchids in that area. And then you get these sandstone, where the sandstone outcrops, so you get these barren areas, which have these really neat prairie fauna. So you have this island of prairie surrounded by like bald cypress. It's awesome. There's some really neat places, neat plant communities you can find in East Texas in very unexpected places. But it's all, again, to the beginning of my talk, it's all comes down to the area's geology. And again, this is right on the coast. We have coastal marshes, and these are old Brazos River channels. Again, this is all delta land. Now, it's not that the rivers made land out in the bay. These are fluvial deltas, meaning as the rivers came out of the highlands and they hit the flat coastal plain, they started making these deltas. These are deltas that were formed inland. So this formed when sea level was lower. As the ocean came back up, it inundated the delta. And what you get are these really cool areas of salt marsh and fresh marsh. Salt marsh near the edge of the bay, fresh marsh further inland. And then you still have these little blowout ponds, and you still have Mima Mounds, tiny little dots, it's hard to see, but Mima Mounds everywhere, even the little round wind-deflated pothole wetlands. These actually are on it. This is an ancient barrier island, 120,000-year-old barrier island. When sea level, 120,000 years ago, sea level during the prior interglacial period was about 10 feet higher than what it is today. So this was essentially Galveston Island 120,000 years ago. But you have deep sand, so again, you get the wind form these Mima Mounds and these little blowout ponds inside of there. So you have, again, an incredibly diverse plant community, all tied to the site's topography and soils.
Where did you say that was?
This is Chocolate Bay. This is West Bay. This is the Brazoria National Wildlife Refuge. It's all National Wildlife Refuge. You can go on out there and check it out. You're going to have to do a lot of walking, though. There's no roads. So. But it is, if I have one regret, it's that I'm getting older and I still haven't walked across. I want to just, when I see pictures of this, photos of this, I want to go there. And I do that still. But I'm getting slower and slower. Again, in regards to our native plant communities, one of the other things that's affected them a lot, other than farming and urbanization, is subsidence. So, people are worried about sea level rise with global warming. Well, we've already experienced a massive amount of sea level rise because of subsidence. When I first got here in 1990, there were no salt marshes. From Texas City on up to Houston Point there, they had all been lost to subsidence. All the salt marshes you see on the west side of the bay today have been planted or have grown from seed, from stuff that had been planted. The only salt marsh that was left was in the cemetery there on Pine Gully in the town of Seabrook, right where Moss's nursery is. There's a little cemetery there. We were saving the Spartina grass between the tombstones. The land was so gently sloped that as the land sunk, the smooth cordgrass, the salt marsh, was able to keep up with the subsidence and just kept creeping up until you had tombstones surrounded with tombstones growing up out of the Spartina marsh.
What's causing this subsidence?
Well, this was from, you have two subsidence cones. One was, it mostly was the Exxon Baytown refinery pulling groundwater out for processed water, and then the refineries, I think it was Amoco was the big one here in Texas City, pulling out groundwater for processed water. About 1/3 of the San Jack water is committed to just that Baytown refinery. They use a tremendous amount of water, but also drinking water. So when people realized this was happening, they came up with the Houston Galveston Subsidence District, and they immediately not immediately, between 1950 and 1990, they got people onto surface water. So they built the Highland Reservoir, they built Lake Houston, they built Lake Conroe, Lake Livingston. All that is to stop subsidence. We still have subsidence today from oil and gas withdrawal for the most part. It doesn't matter what kind of fluid you pull out of the ground or if you depressurize a gas field, the ground still sinks, whether it's oil or whether it's water. And of course, oil produces probably more water. Most wells produce more water than oil. So we still have subsidence, and that's really, if you look at Louisiana and they talk about the canals bringing in the salt water and all, and I argue with all my Louisiana friends, all my LSU friends who work out of Lafayette and all, for the most part, it's not the canals, it's not the salt water, it's subsidence from the oil and gas production that's destroying the marshes there in Louisiana. The Chenier Plain, the geologists, if you look at Tornquist and the other geologists who know what they're doing there in Louisiana, they've shown definitively that the Chenier Plain, there is no natural subsidence in the Chenier Plain. It's an old geologic feature that's been exposed many, many times during low sea level periods. There is no natural subsidence in this area. It's all human caused. All the loss of the Chenier Plain marshes, that's us. That's us. It's not even sea level rise yet. That really hasn't hardly kicked in. We've only had maybe 16 inches of sea level rise. All that marsh loss, all that loss of Louisiana, most all of it, other than in the active Mississippi Delta, is subsidence caused by us. Still being caused by us. Richard Benefield, used to work for Richard Benefield, has a home right here in El Jardín. He got some money from a gas lease. He's like, guess what? Some guy's leasing part of my property's gas well. Jim Jabot, a geologist with the University of Texas at the time, said, oh, this is a great opportunity. He used not LIDAR, something even more advanced than LIDAR to look at topography. My buddy's land sunk 9 inches when they put that gas well in. And that sinking occurred over just a couple years. And when Jim Jabot looked as he plotted the pressure of the gas well, as soon as the pressure, you have a real quick drop in a gas well where production is real high and then goes to real low. Right at that perfectly timed with the drop, the exact amount of subsidence that he predicted in his subsurface model happened, 9 inches. I asked Richard, was that money worth losing 9 inches of elevation when you're right on Galveston Bay? I don't think so. But what happened, another native plant community, seagrasses. We used to think that seagrasses were lost because of pollution, but if you overlap that subsidence map on the loss of seagrass map, you realize it's just the stuff. I mean, Trinity River was horribly polluted, back, it was just an open sewer for the city of Dallas for a long time, and yet the grass beds were never lost in the Trinity Bay. It's subsidence. So you can't take a seagrass bed and suddenly stick it in water that's 6 feet deeper and expect it to exist. So we've got our seagrasses back, but what happened is what used to be upland prairie at Galveston Island State Park, this is well documented, what used to be upland prairie is now high marsh. What used to be high marsh is now low marsh. What used to be low marsh is now seagrasses. And what used to be seagrasses is now open bay. It's just it took a long time for the plant community to catch up with subsidence, because subsidence for the most part is halted in most of this area now. So everything is coming back into equilibrium. This is one of the things we've done out at the state park is we've restored a lot of salt marsh by using dredges to excavate sand off the bay bottom and actually pump it back into the area to raise the elevation up. At first we thought it was erosion. Folks thought it was erosion that was causing marsh loss, so they would build like a wave barrier, and that really didn't restore anything, so they just brought in the sand and raised the land back up, and that did the trick. Again, this is some high marsh. This is the stuff that if you walk in all day, your knees will be bleeding. It's black needle rush. So, and this is that area, the high marsh This is at the Brazoria Refuge. That photo I showed you, the color infrared one with the purples and blacks and blues, this is what it looks like, where you have these round ponds, now partially inundated by the tides, support black needle rush, and then you have the upland prairies surrounding that. Actually, this is black needle rush in this pond. This is a freshwater swale, and then the brown stuff in the background is little blue stem prairie. And it's just a gorgeous landscape. If y'all haven't been out to the Brazoria Refuge, you need to go check it out. It's 50,000 acres of prairie. Where else are you going to find that? You know, prairie and marsh. It's just gorgeous. You can. It's a hard thing to love, I guess, but it's beautiful. You know, it's not like the mountains or anything like that. So I think this is the last community I'm going to talk about, are barrier islands. This is Matagorda Island. If y'all haven't been able to get out there, you need to. Most all of Matagorda Island is public land now, so you need a boat to get to it. And there's really no way to get around out there other than on foot. That's the Matagorda Lighthouse. They used to run a ferry out there for visitors. We couldn't afford it. But these barrier islands are built up of, they've accumulated out into the Gulf. Sandbars, the sandbar would accumulate and rise up and actually form a new beach. And then the land between the sandbar, the new beach, and then the old beach, you have this lagoon that would essentially become a freshwater marsh, and then this would happen over and over again. So you get these ridge and swales. You have dune ridge, swale, dune, swale, dune, swale, like that across the entire barrier island as the island formed. These islands on the Texas coast are only maybe 5,000 years old. They're not that old. But they also have a coastal prairie. They're dominated by coastal prairie as well. Now you have areas of deep sands, high sandy pockets. You'll have live oak mottes with some really cool rare plants like the Texas persimmon, which is usually thought of as a hill country plant. You'll find Texas persimmon on some of those mottes. You'll find things like little leaf Hercules club, Xanthoxylum frugivora, right? Yes, frugivora. And then things like some stuff that you'll find on alkaline soils in South Texas, you'll find on these barrier islands, because you get like Indian middens or other shell deposits. So you get an incredibly alkaline soil on a really dry, sandy environment. Stuff you'll find like in the arid parts of the Rio Grande Valley, or in the hill country you'll find down on these barrier islands. Another one is Foresteria, the privet, Angustifolia. I don't know the common names. Do you know these common names? Well, you know swamp privet, there's like a West Texas version of that, or a South Texas version of that you'll find on these barrier islands. It's really neat if you can come to the right spot. So if you go to Galveston Island, Lafitte's Cove, the development there, they set aside a park area. I think it's off Setagast Road. I can't remember. But it's George Mitchell's development where they, it used to be the three trees when Jean Lafitte, when Cabeza de Vaca came to the Galveston Island, he said there was just 3 trees on the island, and that's where the Indians had their encampment, and that's where the Indians, they buried people there. And it was just one of these wives' tales. Jean Lafitte, you know, met the Indians under there, and they had their little camps, and they buried their people. And then nobody believed it. And then when Mitchell developed that, what'd they do? They just dug up Indian after Indian after Indian. It was like 40 graves, you know. It was like, oh my God, this was really it. So they reburied most of them in the smallest area possible and saved the big trees. And that's a little park, and it's a public park, but you won't ever know it because they don't want, it's the people that live there want it as their park. But you're welcome to go park there and go walk into it, and you'll find some really cool plants there, along with some huge live oaks. But also Galveston Island State Park has some beautiful prairie in it. The heck had been grazed out of it, but we're bringing it back. So because it had been affected by very heavy grazing, a lot of the tall grasses are missing, but a lot of the forbs are still there. So we've got a really dedicated volunteer crew that's reintroducing the tall grasses, the little blue stem and tridents and brown seed paspalum, dunes paspalum. My brain's just not working right now, but there is what's called strand prairie, which another name for a barrier island is a strand. And the strand prairie is just a subset of the tall grass prairie that can handle salt. So you don't find like big blue stem or Indian grass, but you find a lot of the other stuff. And you get, again, the ponds and all. It's just that's our restored prairie right there. And you get these really cool little motts. That's who knows that? Fork-tailed flycatcher, yes, it was very popular. Again, we get flatwoods as the last plant community I was going to talk about, but we're really running out of time, so I'm just going to wrap it up. Just talking about our vertisol soils, back swamps down in the Brazos River, San Bernard River Valley. This is at the Rain Crow Swamp at the San Bernard Refuge and the Nanium Stringfellow Wildlife Management Area. Another awesome place to go visit. If you go to the big tree on the San Bernard Refuge, this is right next to where the big tree is. It's just get on a pair of hip boots and start walking into the water. It's really cool. This is all from, pictures are all from that spot. So it's just, appreciate your time and patience.